Right. So today we're going to be hearing on what do we mean by solving alignment and the implications for research strategy from Roman Leventov. So please go ahead whenever you're ready.
A few disclaimers. First, when I was trying to write this presentation, I realized that probably the content couldn't be titled "What do we mean by solving alignment?" Like the content is something different, but I couldn't come up with better name, so I kept as it is. Second, there is not actually. I wrote quite a few slides, but most content of those slides is sort of, when I was writing it seemed to me quite self-evident and trivial, and the very core claim which I will make, which will be on one of the slides and which is in the description of this discussion. I don't have really very substantive sort of basis for doing it. So it's more like just philosophy of science, maybe like vibes-based claims that we cannot capture the totality of complexity of behavior of systems such as humans and societies with just one compact mathematical theory. But so I just leave it as a claim, and I don't actually prove it because I don't have something to show that substantiates it further than I just claiming it. And if somebody has something to say, maybe to show that this is not the case, then I would be actually interested in invite people to do this, because if people convince me that this is not the case, then I will be fine. Like I'm interested in this position. It's more just the default position which I invite people to sort of offer counter arguments to. Okay. So first, I will start with just a description of some aspects of general intelligence. So this is like a philosophical-ish sort of ontology. It is not based on some like rigorous theory, but it's more for establishing the terminology. So apart from mathematics and logic and epistemology, semantics and rationality, which I define as written on the slide. I think of aesthetics. So models of reality, like learning theory, basically. Semantics is how we understand how those models attach to the reality, like what is the relation between symbols which correspond to some variables in the models to the actual reality. Rationality is when we try to optimize some functions or optimize some utilities or optimize some decisions for some goals based on some models. And then I think of aesthetics and ethics as some functional elements of general intelligence, which is basically everything that is not described by those. And this is not even uncontroversial. So some people think that actually there is nothing except epistemology, semantics, and rationality, that those three and logic just describes the totality of general intelligence. I think there's still something more, and maybe this is the difference between moral realism and like aesthetic realism and constructivism. So if there is constructivism, there is still some style which we cannot just describe rationally, like of how do we actually choose between goals, for example, our goals and goals of our family or our society. Like if we can describe everything just rationally, then there is no ethics, right? There's just, we defined it away, we reduce it to rationality and to epistemology. But if there is still something which we can describe, then there is. And for the purpose of this talk, I assume that there is something else. Then thinking in terms of those aspects, basically the first 4 aspects roughly is what we should implement in AGI for it to be actual AGI. Like, okay, it implements good theory, like process theory of epistemology, rationality, logic, and semantics. Then it functions as capable AGI. And then alignment is capturing some style, which is ethics and aesthetics, like how it should decide between this or those goals, like this or those causes, etc. And I was very careful to choose the language of this point. So I didn't write like impart AGI the ethics and aesthetics that ensure human flourishing, or that we should just narrowly align ethics and aesthetics of AGI with our own, because like we just want them to coincide, because all those subtle framings, they imply some already either like ethics lock in, or imply that our society is already aligned and it knows where it goes, and therefore we can like align AGI with societal values and goals, but then maybe it just moves faster towards the cliff. So even the concept of alignment, maybe it's still sort of not the right naming for what we want to do. We want to have some style which sort of saves us, but like we also recognize that our own ethics and aesthetics and own values, or how they implement collectively, they are very sloppy and probably self-destructing. So like we want to do something better than we do already, but we don't know yet what. So before, what I saw, there was no theory behind it. It was just like just words. I was just saying some words, some philosophy, basically. When we move from this like philosophical talk to actual engineering, like how do we actually engineer like some style, we don't know what style yet, but some style of behavior into AI. Like if it is engineering and not just, oh, let's just try something, because I think currently behind like RLHF and other approaches, it's not like engineering in the sense like alignment engineering, because there's no like theory of like actual mathematical theory behind it. It's just trying something and seeing how it works. Either it fails and like it does everything that we want, or we are all failed and then somehow like deceptively misaligned, etc. So there is no actual theory of alignment behind it. And if you want to make it actual theory of alignment, then there should be some mathematical, not theory of alignment, but actual engineering. There should be mathematical theories behind that engineering. And so before I even didn't say words like values, because I think values are like human values. This is like very common phrase, let's align AI with human values. I think human values are already sort of reductionist view of on the style of ethics and aesthetics in AGI which you want to blend, because for instance, it is just the only things that most humans can recognize could become sort of like called with some word and become ethics and aesthetics, because otherwise if for example let's assume there is extremely empathetic person which is like 3 sigmas outliers on the empathy scale among all humans, and this person like understands some values much better than basically everyone else which they talk to, but because it couldn't even describe it to other people, she or he doesn't even create a word for it, because she couldn't or he couldn't even convey this to other people. And this sort of understanding of something that should happen or how ethics actually should be, like it reminds with this person. It doesn't become the word which we can say, oh, this is like fairness, for example, or this is, you know, bravery or some other value. And even if we abstract from this observations that values are already sort of reductionistic to some degree, there are multiple mathematical or semi-mathematical series of values, such as shared theory, which is in turn based on RL Baron-Millich computational anatomy of values, LeCun's emotional costs model in his vision for machine intelligence, and other mathematical theories in terms of which we can talk about values, like theories which try at least to define them, and based on which series we can actually do some engineering of alignment. And so this is like the core claim that, as I already said, I think that no single compact mathematical theory can describe everything that we need to know about human societies and AI styles, that is like ethics and aesthetics. And the reason is that so brains, societies, and even deep neural networks. Well, deep neural networks are not very good example, but brains and societies, they have a lot of moving parts. They are not like uniform, and like, so the metaphor here would be something like ideal gas. Okay, ideal gas also has a lot of moving parts, but it looks roughly the same across in all directions. So we can just aggregate computations and take some mathematical limits and arrive at some aggregate behavior with really few variables such as pressure and temperature, etc. But brain is not a gas. Like there are different regions of the brain, highly specialized regions such as cortex and basal ganglia and other regions. And we can describe this complex system, I think, just with mathematical theory, which vastly reduces the complexity. Like it just compresses a lot of variables, but then like where did all the complexity of this much larger number of variables did go? Like if we can reduce like human brains and societies to such vastly few variables, like why did we need these complex brains in the first place? It would not be energetically parsimonious, and like evolution would not create them in the first place. And so to be honest, like I think as I understand, like infra-Bayesianism claims that it does it can explain like intelligence of humans with compact mathematical theory. To be honest, I didn't actually read through infra-Bayesianism, right? And if somebody understands it and could explain like why it can like cross this problem, which I don't see how it could cross, I would be grateful. And yeah, a few examples to illustrate the previous claims. There are multiple mathematical, like compact mathematical series that claim to explain like any intelligent systems, such as brains and societies, but they're not complete. So, for example, active inference, or which is also called Bayesian mechanics, it is called it claims very wide reach. Like it claims that it applies to societies, to humans, even to bacteria, like to basically any complex system, but it doesn't claim that it describes them exhaustively. It sort of it's rather descriptive theory which describes what has already happened rather than predicts what will happen. And yeah, utility maximization, I think it at best describes the rationality aspect of intelligence rather than just a total picture of intelligence. There is also interesting framework which I think most people have not heard about. It is Venturin's neural network framework, which is basically he takes neural networks to model everything, like just from complex systems such as humans or societies to even elementary particles. And the idea is that, so the idea is clever, that he sort of wants to capture the physical laws that govern behavior of all systems like this. He like tries to piggyback the idea that neural networks are universal approximators, and he says, okay, like particle behaves in a certain way, maybe a quite simple way. Human brain behaves in vastly more complex way. So we would need a much larger network to capture its sort of the function of behavior of the particle or human or entire society. And then if we like experimented and found that we can train a sufficiently large neural network to model like human behavior, for instance, then we can look at the invariance of the behavior of this neural network, or in case of like elementary particles, same thing. We can train neural networks to behave like elementary particles and then look at the invariance in this network. And it is from this like as a mathematical theory, it is cheating because it seems to me that it collapses to brain-like AI agenda. He basically wants to model humans in the entirety, and then just yeah, from the brain-like AI agenda. Like I don't oppose to this. I think if we would create AGI through just completely faithfully modeling human behavior like in its entirety, which to me it seems that just we cannot capture it without like almost complete brain simulation in brain-like AGI. Then of course it works. I have no issues with this, but this is not a like compact, simple mathematical theory which somebody could invent on the tip of the writing pen. And so if we have those different compact mathematical theories which don't completely capture the complexity of behavior of these intelligent systems, then there are two basic practical ways to bring those theories to engineering actual AI. First is to create more faithful and more like accurate series of cognition, probably human cognition, by combining multiple simpler mathematical series into those like cognitive architectures or Frankenstein series, which I think LeCun's path toward autonomous machine intelligence is example of, and Baron Millige's computational anatomy of values is also like where RL is used to some degree, and Bayesian learning is used to some degree, like predictive processing used to some degree. Like everything is combined, everything is like composed. But I think this approach couldn't be used to model societies because societies are not, well, maybe I'm wrong. Maybe there are some natural abstractions which form in each society, and there is some certain structures, but I'm not sure about this. But this is not the central point, whether it could be applied to societies or not. And the second approach is just to use those different mathematical series sort of one by one. Okay, first we take brain and model it, let's say with RL, find some like inverse reinforcement learning, find something about like human utility function or loss function. Then we model the same human with active inference, find its word model. Then we like reverse, like fine tune, for example, LLM on the all human outputs, and this would be sort of way of modeling human as a language model, which is popular right now. We all find ourselves as having language model like models in our brains, etc. So just applying different mathematical, and the third example is of course not mathematical model, but it's more like engineer model. Anyway, applying different models like one by one to the same system. And so the implications of what I said before to me is first that different compact mathematical theories such as decision series based on utility maximization, active inference, infra-Bayesianism probably, but I'm not sure, and system level synthesis, like they neither correct and neither they are like wrong. They all capture something about style of behavior of complex systems such as humans or societies. Maybe some of them capture like less, maybe more. It is even hard or maybe even impossible to measure actually, like how do you actually say like what % of behavior you capture, because there is no like obvious measure of it. But I think they're all incomplete, yeah, and this is open to refutation. Then second implication is that yeah, so those series, I think they don't compete, but they should be used like in parallel or combined in those more like Frankenstein combined models to reverse engineer humans and societies ethics or values in more narrow definition, and engineer them back into AIs, or not engineer them exactly. Yes, as I said before, I'm not sure we should like just mirror values or human ethics into AI, but maybe anyway, to understand what ethics we should engineer into AI, we should understand our own ethics first, I think. And yeah, this is not, the third point is not like implication, but important point is that, okay, like let's say we have, let's take the example of yeah, utility maximization is fairly widely like used and known, and I think it's plausible that like AGI labs such as OpenAI, Anthropic, etc., they will try to like do inverse reinforcement learning on the LLMs to understand like what is utility function of LLMs, for example, or they will try to extract world models in predictive processing framework from LLMs as well. Not just very tiny pieces of it, but actually trying to make something like a complete world model out of LLMs. Like if they find this tractable, because if you try to do this, maybe it's so hard that it would be easier to just change the architecture from the in the first place. But to apply those approaches, it is costly on many ways. Like first, you should convince like leadership of those labs to actually use those theories. Then, and to convince it is hard because if they bite the bullet and start using this theory to like check, for example, how LLMs, like let's stick to inverse reinforcement learning example. Like if they decide to check the loss function, for example, as some marker of embodied value of LLMs, for instance, they need to implement engineering systems that like all the iterations of LLMs that they train, they need to apply it to every single iteration. They need to create like production pipelines, delivery pipelines for this. So there need to be teams of people who understand those systems, who can support them. So it's a lot of engineering and organizational cost. And even in some cases, it could add up to the latency of actual production systems. It's not just like evals style, but also like online monitoring in some way, like with there is sudden like loss, like bad value in this in inverse reinforcement learning based loss in the LM as it made some certain inference, for instance. So it could add up to latency of the system and make the product less competitive or cost more in inference, etc., etc. So they could not apply infinite number of those series. Like if we apart from like inverse reinforcement learning and word modeling and maybe infobayesianism, let's imagine we designed like 5 more such mathematical series. Like should they add this organizational costs to the companies, like applying all of them, and who decides this, and like whether all AGI labs should do this. So these questions are very much open. I would say it's hard for me to believe that they will do this more than, to be honest, for 1 or 2 frameworks. So okay, maybe they will do inverse reinforcement learning if they stick, for example, with LLM paradigm, with the current LLM paradigm. They will maybe try inverse reinforcement learning on top of it, but currently it even seems that they don't try even that. So I don't know. Yeah, and so the high level implication, I think it's sort of methodological sort of plea to the community that I don't see in this with respect to all that I said before. I don't see the value in creating more of those like mathematical series, but rather to stick to existing series and trying to maybe make AGI labs applying even them to their state-of-the-art models, because currently they don't do even that. They just create LLMs without proper like value alignment based on mathematics, rather than just okay, just vibes based. We just align it on some texts. And the caveats that I want to apply to all the previous, I think I think everything that I said before is maybe more relevant when we even talk about this like unitary agents, which are general intelligences. I rather didn't think through how does this apply to the case if the like technological evolution will rather move into the direction of spreading out of intelligence in some open agencies or some models, some smaller networks which implement some functions and factor recognition, because this also could happen rather than like making self-contained AGI. Maybe some of the reason which I did before still applies, maybe not. I didn't think through it. So that's it.
Fahad, you have a question?
Sorry. Yeah. I think I may have missed something, but I don't fully see how the arguments presented in the earlier slides map onto the implication that so the implications mentioned in slide 9, I think, that that we need to marshal efforts behind no more than 5 theories. I'm not sure which I'm not sure how did we get to this implication. So if you could briefly sort of like recap what's that leading from.
It goes from the reason on this previous slide. So I think then none of those compact mathematical series that already exist, like this whole like idea and this whole talk is sort of pushing against of I think the quite widespread idea that we need to find some new mathematical theories that somehow will capture everything that we cannot yet capture with either like utility maximization agent modeling or like predictive processing agent modeling or infra-Bayesian agent model. Again, I make a caveat about infra-Bayesianism because I don't know the details of it, and maybe it actually claims that it captures everything. And system level synthesis even doesn't pretend it. And yeah, all previous series like utility maximization, active inference, and system level synthesis, neither of them really pretends that they capture everything about agents.
And we're talking about theories both of agency and of alignment, or are we talking about theories of alignment specifically?
Those theories mostly are like the general theories of cognition and agency, I would say. But of course, if there is general theory of agency and cognition, it captures something about what I called on the first slide, aesthetics and ethics, like something about the style. They can also capture, but they also should capture all others. So those aspects, they are not based on some particular like model framework. Like for example, in active inference, you can point your finger where is rationality. Quite simply, you can point your finger where is epistemology. Semantics is not very clear, and aesthetics and ethics you cannot really point. Like it's spread out on the theory. But all those like mathematical frameworks, because they claim to describe intelligence in some way, they may be like the descriptions that they provide, it overlaps with this like style of behavior of the system. But my claim is that it could not completely like describe the totality of what we should know about the system. It cannot describe the totality of its style of behavior. I'm not sure if it is clear.
Yes. So in that case, the implication is that the implication in slide 9 again, is that an implication for theories behind describing agency and intelligence and cognition, or is that also theories of alignment? And if it is theories of alignment as well, is that a sort of a weak claim? Because theories of alignment depend on the theory of cognition and agency somewhat, or is that a strong claim? Because I don't see if that could be a strong claim on theories of alignment.
I don't follow the logic. So this applies to theories of cognition and agency, but for me, like alignment engineering should be based on those theories. Like it could not be based on anything else. Like on anything else, it's just like thinking and trying something out and throwing it in the world and seeing how it behaves. Like we could also do that, but the chances that we will die are very high then. So to me, it seems that therefore it's like stronger claim, not weaker claim, or we don't understand each other.
Let me reframe my thoughts and I'll perhaps ask another question.
Anybody else have questions?
I could, although I'm interested in tackling some of these things. So the main bottleneck that you're identifying is basically that the top companies are going to, they're bottlenecked by the alignment tax, basically. So we need to find a way to present them with some limited proposals. You can't give them too many proposals. They can't implement too many things simultaneously because the alignment tax is going to be too high. It's going to be too costly for them in comparison to other labs to implement all of this stuff. And this is why we need to sort of limit like the complexity basically that we ask of them. And this is the idea of why we are limiting the number of theories that we want to work on, because we want to have like fewer theories that we have worked out really well. And we present them like the best one or the best ones to the lab, and maybe there's some, there's some redundancy in there, like maybe you have 3 or 5 theories, and as long as they sort of agree on some design principles and so on, then that's very good. And with the other things, maybe you still have to work that out and so on. But like the main bottleneck is basically that we have to come up with proposals that AGI labs will actually implement, and alignment tax is like the main consideration here. Is that correct?
Yes, I would also add that okay, of course we shouldn't present them theory which is just completely bonkers or something, but I would even to be honest say that we should try to stick to theories that already exist. Like for example, okay, utility maximization. Let's try to inverse reinforcement learning on LLMs, for instance, and let's try to like understand maybe also how this applies to humans, find also some aspect. Although, to be honest, yes, so the problem is inverse reinforcement learning and Venturian theory as well, neural network framework. I don't see how it is tractable to actually inverse reinforcement learn like on humans in the totality of the behavior. Like you can inverse reinforcement learn, I don't know, on behavior in some game with symbols where you can have the digital blueprint of everything that human does, but just the totality of behavior seems intractable. But maybe this applies to all such frameworks. So in this case, there is no difference. But yes, I agree with what you said. I would just add that I think the simple mathematical frameworks such as utility maximization, active inference, and others, they're not that bad that we should like think that we should even try to find to something else. I would say we should try to reinforce them as existing and try to push them to being adopted by the labs rather than to try to find some new frameworks.
Okay, but would you say that from these theories we can, you're saying that theories of alignment are going to be based on those, right? And so are they well suited in your mind to construct theories of alignment?
What do you mean by theory of alignment? Scientific theory or engineering theory of alignment?
I'm not framing it quite in that way myself. So to explain super briefly, so alignment to me, or like decision preferences and whatever, that's all just like in the first place it's just preference over world states. And you can be very fancy with that. Like there are innumerable ways of assigning preferences to like some aspects of world states. You can also have some like weird preferences over like path dependencies and so on, like you want to be in futures that have a certain past and so on. So that makes you care about how you get to that future rather than just being completely like however you get to the result is fine. And like there's just that aspect to it, like how can you like how do you get to a good understanding of just the different ways to have preferences over world states that are, you know, that are perhaps compatible with like how you would generate something like this from an active inference framework, or if you're rational, right, maybe you don't have conflicting preferences and so on. You get different stuff there. And like the second aspect to that is just, okay, how do you, like if we recognize humans and maybe AI as two systems with preferences over world states, how do we want the relationship between those preferences to be in terms of, okay, now the AI establishes some relationship between its preferences and our preferences, and you can formalize how that relationship is supposed to look like. And this is the thing that we're supposed to aim at. I don't know whether you would certainly use sort of empirical stuff to sort of figure that out, but it seems mostly scientific.
Okay, everything that you described is sort of alignment procedure in the context of certain theory. In this case, it sounds vaguely as predictive processing or active inference, because okay, preferences over future states is more about predictive processing rather than about like utility maximization. So in what I described, okay, if we apply this framework to let's say the latest crop of state-of-the-art AI, like trying to figure out what its preferences over future states are versus what our preferences of future states are. So this would be one aspect of engineering pipeline through which AGI labs would ideally align the latest AI. So, okay, if they do this is great. Then we can take some very different theory, let's say system level synthesis, and we compute the matrices in the theory. I don't know any details about the theory, but it applies some different like model and framework to capture the behavior of systems, basically. So we can also compute those matrices for humans, for LLMs, for instance, if it is the latest AI, compare them in some way. So this would be our second way of aligning. If we even take this frames that we should actually like match one-to-one the behavior and style of behavior of AI and humans. And so AGI labs can use just one of those frameworks or two of them, maybe none of them. So yeah, and this would be the engineering theory, like what they do, 1, 2, or 0, which I think is the current state.
I think without going into this too much, like it seems like it's necessarily the case that any other theory must also be reducible to preferences of our world states, including utility maximization, because it just appears like a fully general framework, but maybe this is not the native way in which you would express it. And so in multiple theories, we're sort of just looking for redundancy.
Of course, those theories like they will overlap. Like if you aligned in terms of like embeddings of the preferred word states, then of course if you take then try to like learn the loss function of humans and loss function, like utility function of human and utility function of AI, they would already overlap. But there will be also something that doesn't overlap. Maybe they will overlap completely. I don't think they will overlap completely, but who knows?
Okay.
And then if you apply multiple frameworks, we just hope, oh, maybe in some out of distribution generalization cases, like maybe on training sets, they all overlap, but maybe in some cases they will not overlap. Can we prove formally that they will overlap like just in any case? Probably we can't.
Okay, sure, yeah. That makes sense. One other sort of question in this area is, so is it not preferable to just aim at, I don't know if everyone is familiar with this concept of long reflection, but like if we are on the on the precipice of building an AGI? Is it, and the alignment problem, like what to align it to exactly, seems pretty hard. Should we not sort of more so double our efforts or like focus on formalizing non-interference, like some safe way for it to exist, and do just very limited stuff where we are extremely certain that this is what we want, and just try to engineer it such that we have a longer time period to sort of figure out what the actual like enduring theory of alignment is supposed to look like? Or do you think that's incompatible with these considerations?
I think yes, I probably should have added to the caveats that probably this framework. So what you described to me, it sounds like super alignment by OpenAI. Basically, they also want to little bit align the first AGI, like alignment MVP, and then task it to like solve everything, like epistemology, alignment.
Well, no, let me rephrase in that case. So it's about sort of reducing the alignment effort. So aligning it perfectly to sort of human values in a way that we'd be happy with in the long term seems like a more difficult challenge than building something that is just safe and can do some limited tasks that are helpful, like, for instance, preventing some kinds of scenarios and otherwise have a strong non-interference principle. Because that is just much less nuanced. And you were emphasizing the sort of nuance of like that it's not detailed enough, theories of values and so on.
I think it continues the yesterday's discussion about satisfying AI paradigm. Like, can we do something limited? Do I understand correctly?
I wasn't part of the satisficing discussion, but sounds like that could be correct.
So I cannot like off the top of my head answer this maybe very well, but it sounds to me that okay, this is a different like basic paradigm which we think like as a community of more like independent researchers that, for example, AGI labs should take. So okay, we can advocate them either to take the parts, okay, please make some limited system which just doesn't interfere too much, maybe it satisfies in some this way, or rather you create system which is not limited in those ways, like you just max out capabilities if you can, but you try to align it very well. Or as OpenAI apparently does, they want to align it enough to make alignment research and then task it with element research. So those three approaches, they seem like all three little bit different approaches. And then the question is, yes, indeed, like which approach is easier to advocate, or whether we can advocate it at all, and or they just predetermined the path, like, okay, we just take one of those approaches. If they take, so maybe the whole discussion in this basically in this session is about the first approach. I don't remember which number was it, but the approach when they don't try to limit capability, but hope to align it very well. So this all relevant in that frame. If they do something like satisficing, maybe it's hard to say. A priori, it's hard to say which will be more safe, I think.
Yeah, I understand your perspective on this. I'm not sure whether it's necessarily satisfying, but yeah, we can.
Apparently, OpenAI thinks that the third approach, like just create sort of aligned with just without even basic theory AI to task with alignment research. It thinks that this approach is the safest one, maybe.
Yeah, I'd be interested in discussing that at more length, but maybe not right now. I also don't want to hog the question platform for too long, so anyone else, please feel free to speak up as well.
Can you hear me?
Yes.
Yeah, cool. I don't know if I've understood correctly, so correct me if I'm wrong, but the big takeaway I got from here was more the emphasis on the fact that it, like society and the AI and humans, just basically every part of this problem are complex systems. And so the key takeaway is more that you can't solve that with there isn't going, as you're talking about, it's not reducible to some neat theory. And so therefore, the question is how you live with the complexity. There's a kind of like all models are wrong, but some are useful side to this. And so how you kind of, that's why you don't quote unquote solve alignment. You almost have to kind of take lots of different views at it and try and stitch something together. Is that a correct understanding of what you've been saying?
Yes, this is exactly what I have been saying. And as I said, I don't have like really much theory behind it. And if some people totally disagree, I would be interested in that.
So it's kind of like you can imagine having up-teen alignment components. Each of one does a little, like helps with one thing or another thing, and they all together form a complex system themselves that will have various feedback loops and whatever. And it almost creates a continuous alignment process rather than a solution.
I maybe don't see a room for, well, maybe some element of feedback. So very, very like cursory how I see it. Let's imagine we do pre-training of a very large deep neural network, and instead of just say training it on the loss of predicting the next token, or combining it with linguistic feedback as in the latest anthropic models, perhaps. We also like interleave backpropagation steps which sort of align it on some other measures, like let's say some the word model which we sort of reverse engineered, for example, from humans, and we want to impart this word model from into AI, and we like compute, like have snapshot of the deep neural network at some point, compute word model from it, compare it without, and then backpropagate the sort of different bits. Although, of course, it sounds extremely expensive, so it would be intractable. But something like this, we like interleave, yeah, some steps of aligning with different objectives.
So that's kind of more on the level of actually training the AI. I guess to clarify kind of how I'm thinking about this is you can think of the AI as being, it's embedded in the world, it's acting in the world. There are loads of different organizations that are using it. There are people that have trained it. There are like regulations. There's all kinds of stuff which is all combining to affect what is what's being done to try and align it, and that this itself is a complex system, and that and when I talked about feedback loops, what I meant was that, I mean, this is kind of a property of emergent processes in complex systems. So you would have yeah, I mean, maybe I'm not explaining it very well, but perhaps an easier way of thinking about it is so if you have, yeah, what you described there was one particular technique that you might do in order to try and help align your model, and you might have lots of different ones. So, you know, Anthropic, you mentioned are working on some other things, and there's all kinds of different stuff, and each of those will have a failure mode on its own. But usually when like systems fail, or you know, corporations or just things fail, it doesn't tend to be because individual parts are failing. Well, I mean, it can be, but it's often the case that you get like these relationships between all of the parts in the whole chain that causes these failure events. Yeah, maybe I've gone off topic or something. So I'll leave it there. I don't know if that was interesting.
You say that the like we create extra feedback loops which could spiral out of control, something, or in some failure way.
So it's like, okay, you can imagine that you have a way of trying to align your AI that includes a bunch of different levers that you pull. So it might be certain training strategies, there might be some interpretability stuff, some monitoring, yeah, all kinds of things. And each of these could be working on its own. So you could have like a really great scalable oversight technique or something that's working like on its own and doing well at what you're trying to make it do. And you know, each one could itself be like have a great theoretical basis based on some ideas that people have come up with. But you know, oftentimes if you get a big failure, so something like the financial crash, it's not because any individual component is failing, that you have some much larger complex system that's kind of just it fails because of the interactions between the parts. And I guess when I say, like, I don't know if I'm drifting off topic, but I was what I was taking away from what you were saying was because of this, you know, irreducible complexity and the fact that you need to have lots of different views on, you can't just have one solvable, it's like the solvable way of solving alignment for all of time, and you've got all of these different bits that is inevitably comes into play is how you deal with this complex system of emergent feedback loops.
I guess I will once again try to reframe. Like, are you talking about that maybe even if you try to do those precautions, like try to align the AI from different angles, maybe the failure will manifest as all those theories will fail in some way at the same time because of like the failure condition, like breeding outside of, or like applying to all of those frames?
I guess what I'm saying is that so in order to actually put one of like these frames into practice, you'll have some kind of system that you engineer to make to try and get the AI to behave according to one of those frames, and then you'll have another system that does the same thing for a different frame, etc. Like, it's difficult to say exactly how it would fail, but I guess what I'm trying to emphasize is that when you start combining lots of different things together, all of which have their own like target and their own criteria for success and that have interactions between them, then you end up with novel failure modes that are to do with the interactions and to do with the larger system. And that's how alignment seems to me, is that it's because it's this, if an AI is going to impact on every aspect of society or more, then it's going to be interacting with every aspect of society, and it's going to be really yeah, maybe I've just been confusing and should stop talking.
I think there are feedback loops, but the whole purpose of introducing more of those like alignment frames or frames in which we model values or something like value aesthetics, style aesthetics, is that we actually stabilize the model to something that we wanted to stabilize. Like, let's imagine alignment between two persons. They could try to align just in language. They could just exchange messages, or they could also send each other feedback loops by means of loops, like they wink to each other, they show some signs with like they move their hands in the air, like they show something. Or you could also add I don't know, touch. So the more modes you add, like intuitively it stabilizes alignment. Like, yes, you add the feedback loops in some sense, but because the objective is alignment in the first place rather than some other external objective, it should be like stabilizing feedback loop rather than destabilizing. Very, very like informal sorts. Should we stop? Because I think we are over time. I don't know if the session's just after this.
We are 5 minutes over now. There's a break in between. So we're not overlapping with another session, but we can also stop if everybody's good on questions. Yeah, so
You're muted.
you're muted.
Yeah, so I think Richard's earlier rephrasing of this talk sort of clarified for me what you're sort of coming at. So I want to come back to sort of the phrasing he used, where all models are wrong, but some are better than the others. I just want to so perhaps ask your opinion on, do you agree that even if all models are wrong, the fact that some are better than others means that we don't just stop at whatever models we have, we keep on trying to iterate and get better and better models? And so in some sense, that the claim that no single compact mathematical theory can describe everything we need to know about human societies, and therefore AI styles and ethics, doesn't itself lead directly to the implication, at least not in a strong sense, that we should stop essentially proposing better and better mathematical theories that more and more closely simulate human societies and etc. Rather, it's more concerns around alignment, tax, and urgency of things than the fact that we can't find the perfect compact mathematical theory that solves all of alignment, period.
Yes, I absolutely agree with everything that you said. So my personal opinion is that we should stop just on what we have now and try to like advocate those theories to AGI labs, or improve those theories to make them more likable to AGI labs, etc. So this is not based on some bulletproof logic. It just, yes, my inference based on my extremely short timelines and my perception of alignment axis very high. And so, yes, if you have different opinions about this, yes, we can search for more models.
Okay, shall we break then and then reconvene in an hour?
yeah, let's talk maybe.
All right, cool. Thank you everyone for coming. Let me stop the recording.
Thanks for the talk, Roman.